Hi, and welcome back to the Programming in Ninox Learning Series. In Class 115, when we looked at the external relationship, in Class 116, when we looked at the parent-child relationship, there was a one-to-many relationship. One of these could be connected potentially to many of those. One invoice could have many line items. The many-to-one relationship is a direct relationship between two tables. The many-to-many relationship is an indirect relationship between two tables by virtue of a common relationship to a third table, what we might call the cross-reference table. Let's take a look at our data model to see exactly what we mean. Here we see that we have expanded our inventory module to now include subassemblies. Subassemblies are combinations of products or raw materials in certain quantities that make up a single unique product. For example, let us say that we're a technology business that sells printers and computers. We might take two computers, two external monitors, one printer, and put them all together and call that a two-person desktop package. And maybe if you buy the whole package, you would get the printer for free. When creating these subassemblies, we have a many-to-many relationship. Each subassembly can consist of many products, and each product can be a component of many subassemblies. If we take our previous example and expand it to the deluxe desktop package, that might include 4 computers and 2 printers. It's the same computer and the same printer product that was part of the 2-person subassembly, but it's also part of another subassembly. So when we have this many-to-many relationship, there has to be a third table that serves as kind of the traffic cop, the cross-reference table that connects many records in one table with many records in the other table. So where, for example, here we see a direct relationship between product and vendor, here we see an indirect relationship between the subassembly and the product that is a component of that subassembly. And the indirect nature is through this subassembly componentry table. It is here that we create all the children of a particular subassembly. Looking at our desktop computer package, we might have 4 or 5 different components in various quantities that all make up the one subassembly. Where we have those multiple line items connected to one parent, we see our parent-child relationship. Then, from the child table, we refer to the product table. We see that relationship right here. And that's saying that each one of these subassembly components is actually a product in the inventory table here. This allows us to have many children for each subassembly parent, and for a single product to be represented in many subassembly component line items. Subassembly is related to subassembly component as a parent-child. Subassembly component is related to product with an external join. And that indirect relationship enables subassembly and product to be related by virtue of their common relationship to the child component table. Let's see this in action. Here I am at my subassembly record. I have an Apple desktop package, which consists of 2 Apple desktop computers, 2 extended keyboards, 1 external 27-inch monitor, and 1 all-in-one wireless printer. For each one of these line items, we see that it is represented as a child to this parent, the Apple desktop package. But within each child record, we see the relationship from the component table back to the raw material or product table. This relationship allows each particular raw material or product to be represented in any number of subassemblies, and for each subassembly to have any number of products. One of the other advantages of the parent-child relationship is that just like when you delete the parent, you also would delete the children. Well, that works in reverse. If you duplicate the parent, you duplicate the children. So let us say that this is a two-person package. However, we also want to add a four-person package. So I'm going to duplicate this particular package, rename it the four-person package, and then go in and update the componentry. Now we have two of the external monitors, four of the external keyboards, two of the printers, and four of the desktop computers. And now we see we have our desktop 2 package and our desktop 4 package. The sum total of the cost of the components in the child table are represented this way. I can select to show the field in the subassembly component child table that is the component cost field, and I can ask to get the sum of that field. I then can similarly display in the subassembly child table the package charge sum total. So we can see that the total component costs for the Apple Package 2 are just over $4,050. The price we charge is just over $13,700. The Apple Desktop 4 package has a significantly higher cost, but we also have to go in and adjust the price. So where we have two of these, the total line charge would be about $5,000. Maybe you get a discount for this particular package. So instead of $49.80, we can make it $49.40. Two extended keyboards, it's the same price of $460.10. The two printers have a package charge of, let's say, in this case, $600. Which is to say, in the four-person package, one of your printers is free. And then finally, for the two desktop computers, which have a total cost of $22,400, in the package, they'll only be $22,000. So we can see here that while the two-person package has a $13,700 price tag, the desktop 4 package has a higher price, but also we can see has a greater package discount, over $1,000, where the discount on the two-person pack was only $800. What I've just shown you is the ability to define characteristics of the child that are exclusive to the parent. Here we have the two user parent record. The characteristics of the external 27-inch monitor in this particular package is there's only one, there's no discount, and the package charge is $2,490. However, when we look at the four-person package, this same component has different characteristics. Twice the quantity and a $40 package discount where there was no discount previously. If we look at the two-person package and the four-person package, they both use the exact same components, but we see different characteristics in terms of possible discounts, the number of components in each package, the total component cost. each product differs slightly in how it is represented inside of the parent package where it serves as a component. Before we leave this form, I want to show you a quick trick that you can use to summarize content in all of the children of a single parent. For example, let us say that we want to have a single field here in our parent screen that represents the total cost and the total charge for all of our children. Now we could go in and simply use the sum option for each of those columns. The problem, however, is the numbers are not right justified, and they're part of the child component. They're not part of the parent component. What I really would prefer is to have a field here in the parent record that represents the sum total of some of the data elements in my children. It's really easy. Create a new formula and indicate the numeric function you wish to apply to a field in all of the child records. So here's my child table, and the field I want is the component cost, which is itself a formula. I simply click there, and this tells Ninox to go to the subassembly component table, grab all the children, all the components of this parent, look at their component costs, and sum them up. This will enable us to put an object that represents the total component cost, and the object exists here on the parent screen. Similarly, I can go in and grab the sum of all subassembly components, specifically their package charge. This allows me to create a formula, which is a screen object at the parent level, for the total package sale price. And now that I have these formulaic elements that summarize the individual data elements in all of my children, I can go in and instead of having to calculate these complex formulas, which can slow my system down, I can simply go in and reference the native objects in the parent table. Here the parent table is the subassembly, and in the subassembly table, I can see my total component cost, and I can see my total package sale price. And these formulas are actually the summation of all of the data here in the child records. Many-to-many relationship is not a different kind of relationship. It's a different way to use the parent, child, and direct reference relationships that we already learned how to build. In our next class, we're going to move into some interactive components that allow us to have conversations with our Ninox system. I'll see you then. Visit us at www.nioxis.com. Here you can learn about different Ninox solutions. You can get tech support through our Ninox help desk, which is available 7 days a week, or you can schedule private one-on-one concierge sessions for training, or we can help you build your application. And if you haven't done so already, sign up for our free Ninox Learning Lab. We do this every Thursday at 12 o'clock Eastern Standard Time, 5 p.m. in the UK, 6 p.m. Central European Time. These free hour-long sessions enable you to learn more about Ninox, features, functions, and solutions. We have open Q&A where you can get answers to all your Ninox questions, and you can meet other members of the global Ninox community. We look forward to seeing you there.